Good morning to everyone. This is Dr. Ganapathy Srinivasan, Associate Professor, Department of Mechanical Engineering, Weltech Multitech, Dr. Rangarajan, Dr. Saundala Engineering College. Now we are going to see about that introduction of mechanics and machines for that theory of machines. Now we are going to see about that the kinematics of machines. It's need to understand the concept of kinematics and dynamics. Kinematics is nothing but the mechanism is concerned with the motion of parts without concerning how the influencing factors, that means the force and mass, affecting the motions. Therefore, the kinematics is deals with the fundamental concept. Kinetics is nothing but deal with that action of forces on the bodies. Dynamics, it's combinations of kinematics and kinetics. The dynamics is mechanism concern the force that act on the parts, both balanced and unbalanced force, taking into the account the mass and acceleration of the parts on as well as the external force. So the basics of kinematics of mechanics, it includes the mechanism and machines. The words mechanisms has many meanings. In kinematics, a mechanism is a means of transmitting, controlling, or concerning relevant movements. The movements which are electrical, magnetical, pneumatical, it depends upon that requires certain applications which we are required into that building the mechanism. The central themes for the mechanism is the rigid body concerned together by the some other more joints. So we are going to see about that simple mechanism for using the developing the machines. So the figures is showing like that the reciprocating IC engines, which is used to the combinations of rigid or resistance bodies to form that constrain the move with the defined relative motions, which is transmitting the force from source of power to the resistance to be overcomes. The machines has two functions, transmitting the defined relative motions and also that transmitting force. So now we are going to see about that classification of mechanism. Mechanism can be divided into planar mechanism and spectral mechanism according to the relative motions of the rigid bodies. So it's the planar mechanism is the relative motions of the rigid bodies are planned into that parallel 2D planes. And also that the spectral mechanism is one of that same plane or parallel planes. It's like that 3D. The mechanism is called the spectral mechanism. In other words, the planar mechanism are associated to the two-dimensional, while the spectral mechanism are simply we can say as that 3D, three-dimensional mechanisms. So these are the examples for that simple mechanisms. So now we are going to see about that links. The links, kinematics links is nothing but which is having the relative motions to another parts. It's known as the kinematic links. A link may concern of several parts which are rigidly fastened together so that don't move relative to one another. So it's having a one more that reciprocating engine for that simple kinematic links arrangement for the build the mechanisms. So we can classify the more types of the links. First, we can see about that rigid links. The rigid links which does not undergo any deformations when we are going to applying the transmitting the motions during that applications. And also that flexible links is concerned that some other partial deformation while we are going to transmitting that motions. The fluid links is nothing but it's one of the form of having a fluid in going to motions transmitting through that fluid by the pressure or compression only. So these are the kinematics pair. We are commonly we having the two links or elements of mechanism. It's called as a pair. So when it concerned with that each other or said to that form of a pair, it having a relative motions between them completely or successfully consigned. The pair is known as the kinematics pair. So these are the types of kinematics pair according to that relative motions, which is having a consigned and unconsigned and successfully consigned kinematics pairs. So next we are going to the types of kinematics pairs according to the contact. which is first one is we are going to see about that lower pair. When the two elements of the pair having a surface contact, when the relative motions takes place and the surface of one element slides over the surface of the other pair, form is known as the lower pair. So we can see about that examples of lower pair in that figure. Now we are going to see about that higher pair. When the two elements of pair having a line or contact, point contact, when that relative motions takes place and the motions between the two elements is partially turning and partially sliding, then the pair is known as a higher pair. So now we are going to see about that types of constraint motions. The first one we are going to see about that completely constrained motions, when the motions between that pair is limited to a defined directions respectively to the directions of force applying, then the motions is said to be completely constrained motions. The motions of square box in square hole is as per the shown in figure. The motions of shaft with collar at each end in the circular hole as shown in the figures. So next we are going to see about the incompletely constrained motions. When the motions between a pair can take place in more than one directions, then the motions is called as incompletely constrained motions. The change in the directions of impressed forces may alter the directions of relative motions between that pair. So now we are going to see about the successfully constrained. When the motions between the elements forming a pair is such as that the constrained motions is not completed by itself, but by some other means, then the motions is said to be successfully constrained motions. The motions of IC engines, valves, and the pistons reciprocating inside an engine cylinder are also the examples of successfully constrained motions. When the kinematic, now we are going to see about the kinematic chain. When the kinematic pair are coupled in such a way that the last link in is joined to the first link to transmit defined motions is called as the kinematic chain. It can be said as that combinations of kinematic pair joined in such a way that each link forms a part of two pairs and the relative motions between that link or elements is completely or successfully constrained. If each link in assumed to form two pairs with two adjacent links, then that relative motions of the pair forming that chains. We can found out that what kind of the kinematic chains by using that following formulas like L equal to 2p minus 4. So the L is nothing but the number of links and also that P is the number of pair. So if we are going to solve that, the equations comes through that three kind of the results. LHS is greater than to that RHS, that will be considered as a locked chain. When we are the LHS is equal to that RHS is to be considered to that 1 degree of freedom. When the LHS is less than of equations from that RHS, that right hand sides of the equations, it is to be considered as a unconstrained chain. So these are the examples of kinematic chains, how we can go into that calculator. So now the figure shows that three pairs of kinematic links. It's having a number of links 3, pairs 3, and also the joints 3. The result shows the LHS is greater than to that RHS. So we can say is that it's a locked chain. So now we are going to see about the degrees of freedom. The degrees of freedom is nothing but it's a number of inputs required to that describe that configurations or position of all the links of the mechanism with respect to the fixed link at any given instant. It can be formed by that analysis by using the Kirchhoff equations n equal to 3 into L minus 1 minus 2j minus h. So the L is nothing but it's denoted by that the number of links, and j is denoted by that it's mentioned that number of joints, and also that which means that a higher pair of the mechanism. So for example, they are given us some more links for finding the degrees of freedom. How we are going to find that degrees of freedom by using the formulas. Now we are going to see about that inversions of mechanism. Which one the link is fixed in the kinematic chain, it's called as a mechanism. So we can obtain many mechanism by fixing in turns different links in that kinematic chain. That methods is known as that inversions of mechanism. So the first inversions of 4-bar chain we can called as that the 4-bar chain, getting that three type of the inversions. The first A and B is shows in that the first inversions of 4-bar chain. The C is denoted to that second inversions, and the D figures D is shows that third inversions of 4-bar chain. So the applications of first inversions is known as that beam engine. So we can a part of mechanism of a beam engine, which consists the four links as shown in figures. In this mechanism, when the crank rotate about that fixed center A, the lever oscillating about that fixed center D, the end E of the lever CDE is connected to a piston rod which reciprocating to that rotations of the crank. The purpose of this mechanism is convert rotary motions into that reciprocating motions. So next one is the inversions of 4-bar chain. Its applications is known as that coupling rod of locomotive the mechanism. It can be called as the double crank mechanism, and also that the another one is water indicator mechanism. That double crank mechanism is applicable to the locomotive wheels, the driving of that locomotive engines, and also that water indicator mechanism we can use it to that measuring the pressure in that side of the IC engines. So these are the another inversions of the mechanism, the single cylinder crank mechanism. The single cylinder crank chain is modified of the basics of 4-bar mechanism. It consists of one cylinder pair and 3 turning pairs. It's usually found in the reciprocating steam engine. This type of the mechanism convert the rotary motions into that reciprocating motion, and it can be applicable into that reciprocating engine and also that reciprocating compressor. So these are the inversions of single gearing mechanism. So we can update it in that pendulum pumps and accelerating cylinder, rotary internal combustion engine, crank and slaughter lever quick return mechanism, and withward quick return mechanism. So this is that rotary engine for that applications of the single cylinder mechanism inversions. So next we are going to see about that inversions of double cylinder crank mechanism. So the double cylinder crank mechanism is having a two slider with the 2 turning pairs, and also that it can be updated in that elliptical terminal Scotch arc mechanism and the old couplings. It's having a one of the inversions of the double crank slider mechanisms. So that elliptical terminal is having a forming the elliptical shape of the path when we are going to applying that mechanism. So this is the Scotch arc mechanism. We can getting that the Scotch arc mechanism by using that double cylinder crank inversions of that mechanism. So this coupling is we can using that special applications while we are going to connecting with that the misalignment of axis when we are going to applying that connecting the shaft, we can using that this kind of the couplings. Thank you.